Have you ever wondered about thinking machines? Machines that can learn, just like you. Neural networks are a step in that direction. They are inspired by the human brain. Your brain, a universe of connections. Neural networks mimic this intricate web, a powerful idea changing our world. Why should these networks capture our attention? Their impact ripples through our technological world. They touch many aspects of your daily life. From the way you search for information online, to the music streaming service that knows your taste, even helping to create stunning cosmic images, their influence is growing, expanding like the universe. Let us journey to the very heart of the network. We find tiny fundamental units at work. These are the artificial neurons, or simply nodes. Think of them as individual data processors, each one a small cog in a vast machine. They are inspired by your brain's own neurons. Now, a single neuron is not very powerful alone, just as a single star doesn't make a galaxy. The true magic happens when neurons connect. They are organized into layers like cosmic strata. Imagine sheets of stars stacked upon each other. These layers process information sequentially. Section 3. The ignition point activation functions. Our neurons have received inputs and summed them. They have calculated their weighted total. But there's a crucial step still missing. A mechanism to decide if a neuron fires, or how strongly it should fire its signal. Section 1. Preparing your launchpad, setting up the environment. Before we can sculpt our thinking machine, we need a workshop. A digital space where our creation can take form. This isn't a physical lab with bubbling beakers. Instead, it's a software environment on your computer. Think of it as preparing the launch pad for a rocket. Section 2. Cosmic ingredients, gathering and preparing your data. Every neural network needs fuel to learn. This fuel is data, vast oceans of information. The quality and quantity of your data are paramount. Think of it as the raw stardust from which understanding is born. Poor data is like trying to navigate by a dim, flickering star. Section 3. Designing your Star Voyager. Building the neural network model. With our environment ready and data prepared, we build. It's time to design the architecture of our thinking machine. Remember the layers we discussed earlier? Input, hidden, output. Now we decide how many layers and how many neurons in each. The input layer's size matches your data features. Section 4. Ignition and trajectory training and evaluating your creation. The model is built, your Star Voyager is assembled. Now, for the most exciting part, bringing it to life. This is the training process where the network learns. We show it the prepared data, feature by feature, example by example. For each example, the network makes a prediction. Initially, these predictions will be quite random, like a newborn starship unsure of its course. But with each example, it adjusts itself slightly. Gradually, it learns the patterns connecting inputs to outputs. This is the essence of machine learning, learning from experience. How does the network know if it's right or wrong? We use something called a loss function. Think of it as a cosmic measuring stick for error. It calculates how far the network's prediction is from the true answer. A large loss means a big error. A small loss means it's close. The goal of training is to minimize this loss. To help it minimize loss, we use an optimizer. The optimizer is like the ship's navigation system. It adjusts the network's internal weights, guiding it towards better and better predictions. The training happens in cycles called epochs. One epoch means the network has seen all the training data once. We usually train for many epochs, allowing gradual refinement. Data is often fed in batches, small groups of examples. This makes the training process more stable and efficient. Imagine teaching a student. You give them lessons or batches, and you go through the whole textbook multiple times or epochs. With each pass, the network's understanding deepens. It fine-tunes its connections, its internal weights, becoming more adept at the task you've set for it. Finally, how do we know if our network truly learned? We test it on data it has never seen before. This is called the test set, kept separate during training. It's like giving your starship a final exam on an unknown course. We measure its performance using metrics like accuracy, Accuracy tells us what percentage of predictions were correct. If it performs well on test data, congratulations are in order. Your neural network has learned to navigate the data universe. You've successfully launched and guided your intelligent creation, and this is just the beginning of your cosmic journey. Table of Contents, Part 4, Act 3, about 4 sections. 1. The all-seeing eye, neural networks and image recognition. 2. The universal translator, understanding language with neural networks. 3. Navigating our world, neural networks in autonomous systems. 4. Cosmic canvases, expanding frontiers of neural networks. Section 1. The all-seeing eye, neural networks and image recognition. Our journey now takes us to truly wondrous realms. Where do these thinking machines showcase their talents? One of the brightest constellations is image recognition. Neural networks have learned to see in a way. They can look at a picture, a digital canvas, and understand what objects are within it, like a cosmic observer identifying distant nebulae. This ability is transforming how we interact with images. It's a visual revolution, powered by artificial intelligence. You encounter this magic more often than you think. When your phone unlocks by recognizing your face, that's a neural network performing its complex dance. Or when social media suggests tagging friends in photos, it has identified familiar faces in the digital crowd. These systems sift through billions of images online, categorizing them, making them searchable, understandable. From kittens playing to ancient star charts, they bring order to the visual chaos of our universe. The impact stretches far beyond our daily gadgets. Consider the universe of medical science, for instance. Neural networks are now assisting doctors, a vital role. They analyze medical scans with incredible precision, looking for subtle signs of diseases like cancer, often spotting clues invisible to the human eye. In astronomy, they classify galaxies from telescope images, helping us map the cosmos on an unprecedented scale. Their vision extends from the microscopic to the galactic. How do they achieve such remarkable visual feats? It begins with the raw data, the pixels of an image. Each pixel is a tiny speck of color and light. The first layers of the network might detect simple edges or basic shapes like lines and curves. Subsequent layers combine these into more complex forms, recognizing textures, then parts of objects, then whole objects, like assembling a cosmic puzzle piece by piece. This hierarchical learning allows them to grasp intricate scenes. Let us now explore another fascinating cosmic domain, the realm of human language, complex and ever-evolving. Neural networks are becoming fluent communicators. This field is known as natural language processing, or NLP. Teaching a machine to understand our words is a grand challenge. Language is filled with nuance, context, and ambiguity, like trying to decipher signals from an alien civilization. Yet these networks are making incredible strides. They are bridging the gap between human and machine thought. Think about the translation tools you might use, converting text from one language to another almost instantly. Neural networks are the engines behind this modern marvel. They learn the intricate patterns between languages. Or consider the chatbots and virtual assistants we talk to. Siri, Alexa, and others rely on NLP to understand your questions and provide useful answers. They process your spoken words or typed text, striving to grasp your intent, your cosmic query. These intelligent systems can do even more with language. They can perform sentiment analysis, a curious task. This means reading a piece of text, perhaps a review, and determining if the emotion expressed is positive or negative, or even more complex feelings, like joy or frustration. Some networks can even generate human-like text, writing articles, summaries, or even poetry, crafting new linguistic constellations from learned patterns. The creative potential is truly astounding to consider. How do these networks grapple with the structure of language? They often begin by converting words into numerical forms. Representations called embeddings, where similar words cluster, like stars forming constellations based on proximity and brightness. Then specialized architectures like recurrent neural networks, or transformers, analyze sequences of these words. They learn the importance of word order and context, understanding that dog bites man is different from man bites dog. This allows them to interpret meaning, not just isolated words. Section 3. Navigating our world, neural networks in autonomous systems. Imagine vehicles that pilot themselves through bustling city streets, or drones that navigate complex terrains on their own. This is the promise of autonomous systems, a bold frontier. and neural networks are crucial co-pilots on this journey. They provide the brains for these independent machines, allowing them to perceive their environment and make decisions, like celestial navigators guiding starships through asteroid fields. This technology is rapidly moving from science fiction into the tangible reality of our everyday lives. Consider the self-driving car, a prominent example. These vehicles are equipped with a suite of sensors, cameras, LiDAR, radar, constantly observing the world. Neural networks process this torrent of incoming data, identifying pedestrians, other cars, traffic lights, and lane markings. They build a dynamic map of their surroundings. Then, another set of networks might decide how to act, whether to accelerate, to brake, or to steer safely. All in real time, a continuous cosmic ballet of perception and action. But autonomy extends far beyond cars on our roads. Think of drones delivering packages or inspecting infrastructure, or robots working alongside humans in vast factories, performing tasks with precision and tireless endurance. Even planetary rovers exploring distant worlds like Mars. They rely on neural networks for autonomous navigation and for making scientific decisions millions of miles from Earth. These systems are extending our reach, our senses, allowing us to explore and operate in challenging environments. The development of autonomous systems carries great responsibility. Safety and reliability are paramount, absolutely critical. Neural networks in these systems must be incredibly robust. They must handle unexpected situations with grace, the edge cases, the rare cosmic events. This requires vast amounts of training data and rigorous testing in diverse, simulated, and real-world conditions. It's a continuous process of learning and refinement, pushing the boundaries of intelligent, independent operation. Section 4, Cosmic Canvases, Expanding Frontiers of Neural Networks. The applications we've explored are just the beginning. Neural networks are a versatile tool, a universal solvent for problems. Their influence is spreading like an expanding nebula, touching nearly every field of human endeavor, from the way we shop to the way we create. New uses are being discovered at a breathtaking pace. It's a testament to their power and adaptability, a new way of thinking about problem solving, finding patterns where we once saw only chaos. Consider the recommendation systems that shape your online world. When a streaming service suggests a movie you might love, or an e-commerce site shows products you might need, neural networks are often working behind the scenes. They learn your preferences from your past behavior and compare them to the patterns of millions of others. In finance, they detect fraudulent transactions with superhuman speed, or attempt to predict the volatile movements of stock markets, sifting through cosmic oceans of financial data for subtle signals. In the grand laboratories of scientific research, they are invaluable, assisting in the discovery of new medicines and materials by predicting the properties of molecules yet unsynthesized, helping to model Earth's complex climate systems to understand the changes shaping our planet's future. Even in the realm of particle physics, a truly cosmic scale, they analyze data from giant colliders, searching for new particles, unlocking the fundamental secrets of matter and energy. They are becoming indispensable partners in scientific discovery. And what about the spark of creativity, the artistic impulse? Neural networks are even venturing into these human domains, generating original music in various styles and moods, creating stunning visual art, dreamlike and unique. They learn the stylistic patterns from human creations, then they can remix, reimagine, or invent anew. The universe of neural network applications is vast and growing. Keep your eyes open, your mind curious. You'll start to see their influence everywhere, in every cosmic corner. The essence of neural networks. Neural networks, inspired by the brain, are cosmic detectives. They learn from data, uncovering hidden connections. These systems solve problems, mimicking thought. Layers of neurons process information, transforming data. Activation functions ignite intelligent behavior. We explored their applications, from image recognition to autonomous systems. Neural networks are shaping our future. Section 2. Your universe of discovery awaits. The journey continues. This essay, this brief tour, was merely your first look through the telescope, a glimpse into the vast and expanding universe of neural networks. We've charted the basic constellations, the fundamental principles, but there are countless galaxies of knowledge still waiting to be explored. The field is dynamic, evolving at a truly cosmic speed. New architectures, new techniques, new discoveries are made constantly. What you've learned here is a solid foundation, a launch pad for your own continued exploration into this fascinating domain. Think of it as your first star chart, pointing the way. The next step in your journey is up to you, intrepid explorer. Don't let your curiosity dim like a distant fading star. Dive deeper into the concepts that sparked your interest. There are countless resources available: online courses, books, communities. Try building your own simple neural networks. Experiment with data. The best way to understand is to get your hands dusty with code. Start with small projects, perhaps classifying simple images or numbers. Each small success will build your confidence and understanding. You are now equipped with the fundamental knowledge to begin. Understanding neural networks is becoming increasingly vital. They are not just a niche topic for computer scientists anymore. Artificial intelligence is weaving itself into the fabric of our society. It's influencing medicine, art, science, business, and daily life. Having a grasp of these core concepts empowers you. It helps you understand the technologies shaping your future. It allows you to participate in conversations about their ethical implications. And it might even inspire you to contribute to this revolution. Your unique perspective is valuable in this expanding field. So go forth and continue your exploration of this amazing cosmos. The universe of neural networks is vast, and your potential is too. What you've learned is more than just facts. It's a new way of thinking. A way to see patterns, to understand learning, to build intelligence. The journey of discovery is endless, much like the universe itself. Keep asking questions, keep learning, keep building. The power to create and understand is now closer than you think. The stars of innovation are within your reach. Embrace the challenge, and may your quest for knowledge be stellar.